Hello everyone. Today I want to show you a microtick counter. First of all, I'm gonna explain what are those so-called microticks and what they're good for. So let's start with a very practical example. So in this situation, I want to push this block out and push this block in within the same game tick. Obviously, if a piston is extracted, you can't push anything in there because the piston arm, would block it. So at the moment I couldn't push a block in here, but I can if the piston arm is retracted again. So obviously I would need a zero tick where the piston extracts and retracts in the same game tick, and after he has retracted again I can push in the second block. So if we would try something like this, have a zero tick generator here and just power the other piston with the same delay, so both have the same delay, obviously it wouldn't work. So this piston doesn't push. And this is where those microticks come into play. You could add microticks by chaining piston updates. So for example, to make it work, you could do something like this, have an instant repeater. It also has an update chain, and yeah, with this setup it would work. So the block can be pushed in because the other piston is already retracted again. And yeah, the simplest way to get a microtick is using the difference between comparators and repeaters. So that's one microtick. That's not 100% correct, but it helps to understand it. So, and here is our microtick counter. We have the input line here and here, and if we turn it on, you will see you get 1 microtick of delay. If I would turn it around, then obviously don't get any microticks of delay. Yeah, and I'll try to explain how much microticks you need here. So let's say the repeater is microtick 0, and this comparator would be 1, and then this piston is 2. So the piston is 3, it would retract at 3. Obviously this one has to extend at 4 then. So that's what we're doing here with 1 microtick delay, 2, 3 this piston, and 4. That's why it would work. If we would power this piston directly here, I would only have 3, and then it doesn't work. So yeah, take a look at this, and it doesn't work again. So you need 1 more microtick delay here. That's how it works. I've also set it here at our microtick counter, so there's the instant repeater, and let's see how many microtick we get. Yeah, we get 2 microticks. And if I would do the butted instant repeater like this, then we get, is correct? Yeah, then you get 3 microticks. And here's another example of the same setup. What's different is that we have a different zero tick pulse generator, where the zero tick pulse is longer. So this works by extracting the solid block here, so the red cell line is powered, but in the same game tick also the power source is removed, so the red cell line is turned on and off within the same game tick. And we can also count that. So the repeater is again 0, so this would extract at 1, so the signal starts at 1, and we have an update chain here, so we have 1, 2, 3, 4, 5, so the signal would turn off after 5, and then the piston here would retract at 6, so this has to be at 7, and that's what I did here. So again we have 1, and this type of instant repeater always adds 3 microticks, and that would be 4, but so we need 2 more, so we have another instant repeater which adds 2 more, and then this piston is 7, so this would work. So the block is pushed in. But if I would do 1 less, then it wouldn't work again. So over here I also set up the instant repeater, and so we have 4. So and it will also be displayed by the microtick counter. Yeah, and if we would change the order again, then we would only have 3. I've also added a chain of those instant repeaters, yeah, to show you it's really 3 per instant repeater. So change the order again. So we start with 0, then yeah, it's 9 obviously, and also displays a 9, and then get rid of 1, then we get 6, and 1 more, then we have 3. So the microtick counter could also be used to evaluate the microticks of zerotick generators, and if the setup is a little bit more complex like here, it could be a good help. So we have a setup over here. Everything again is powered on the same game tick. So we send over the send block with a zerotick pulse that is generated here, and this is also a zerotick pulse generator. And yeah, we could measure when the zerotick pulse starts, and it would be basically too long until this piston updates. So let's just push the button, and we see that the zerotick pulse starts at 3. And yeah, that's kind of useful, but you could obviously count it on your own if you want to, but it's really nice to have a machine that confirms it. What's also noteworthy is that the behavior is kinda locational, of course, if you use the redstone dust. So I'll reset it and I'll show you the locational behavior. Here's a quick demonstration of the locational redstone dust behavior. So if you have no repeaters or comparators to influence the update order, it depends. For example, if I power it here, we get 1 microtick delay, but obviously if you power it somewhere else, it could also be 0. Okay, now let's take a look how this works. So we have just an update chain with those pistons. So this one is powered directly, and then all the others would update in a chain. And in the back, depending on when we power this, at which microtick, there's a certain number of blocks that get pushed out. And depending when this happens, then we get it's displayed at how many microticks this happened. So those one would push down, and the other ones would push to the side, because those pistons update before those other pistons that are in the update chain. And over here we have just made a really sloppy 7-segment display to show it visually, but you could also take a look at the blocks here. It would also work. Okay, I hope this is useful for some of you. Have a good day, and goodbye.